So here we go. Good afternoon, everyone, and welcome to this lecture. This is waves lecture number 4, and we are dealing with wave equation, whether it is transverse wave or longitudinal wave. The wave equation remains same. In the previous class, what we had started this velocity and acceleration of the particle, and we had seen the relation between particle velocity and the wave velocity. Do we remember this? Particle velocity is negative gradient of dy by dx, and it is Vp is minus V wave into del y by del x. Do we remember this or not? Remember this? Particle velocity, wave velocity? Don't remember it?
Remember, sir.
We remember, sir. And we were trying to see this was the relation. We remember those relations, yes?
Yes, sir.
And we were trying to see with the help of a diagram, this diagram in particular, how will you find out the wave, where the particles are moving or in which direction the particles are moving. So we'll begin our discussion with the same thing. And how are we going to begin it? We will just give you a bigger diagram and try to understand things from this diagram, which is a good sine wave. So here is the sine wave, and here we start. Now this is point O, and I already told you everyone that this is the mean position of the particle, yes or no? And we had called this point as point A, and we had seen from O to A, how are the particles moving. This is the snapshot of the wave taken at one particular time, and this is how the wave looks like. We have taken a snapshot, a picture of the wave. Do we understand this?
Yes,
That is
sir.
why we get a graph between y and x. This is the snapshot of the wave. We remember this.
Yes, sir.
Now we were trying to find out what will be the direction of velocities of this particle. What will be the direction of velocities of this particle? Are the particles between O and A, and there will be infinite number of particles? Where are they moving? Are they moving away from the origin, or are they moving towards the origin, towards their mean position?
O to A towards mean position, sir.
So from O to A, the particles are moving like this. They are moving towards their mean position. Whereas the particle which is at A, that particle is at, the particle at A is at,
Is that rest, sir?
the particle at A is at rest. Now, which particle, let me ask you, has the maximum speed? And where is that particle, and what is that maximum speed? Which particle has the maximum speed between O and A? Looking at the diagram, you can tell me that. Which particle has the maximum speed, and what is that maximum speed?
Article at O, sir. O.
Particle at O has the maximum speed, and how much is that maximum speed? How much is that maximum speed? How much is that maximum speed? See, we have forgotten simple things.
Huh? A omega, sir.
A into omega. Now let us move from point A towards point B. What about the velocities of particles from A to B? Where are they moving?
Away from mean position, sir.
They will move away from the mean position. This particle is moving like 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 this, and so on. Whereas the particle at A is definitely at rest. Which particle has the maximum speed here?
B, sir.
B, sir. Then you go from B to C and C to D. We will complete one wave. After that, it will repeat its um, thing. Between B and C, how are the particles moving?
Towards mean position, sir. Towards it. Sir,
So
from B to C, it's away from mean position.
B to C, the particle are on the left side of the mean position. Should understand it that way. Or they are below the origin. They're below the origin. Below the origin, they can move like this towards their extreme position, or they will move like this towards their mean position. Where are they moving? They're also moving towards the mean position. They are moving towards the mean position.
Yes, sir.
Do we understand this? Whereas the particle at C would be at
Away. At C is rest, sir.
between C and D. How the particles are moving?
Away from mean position.
So the particles are not moving between B and C. The particles are moving towards the mean position. Mean position is a central line. You can see that, yes or no?
Yes, sir.
Between C and D,
Means towards the mean.
they are moving away from the mean position. They are moving downwards. Do we understand this?
Yes, sir.
Now, the one way of understanding this is moving upwards and downwards. The one way of understanding this is towards or away from the mean position. So now, this pink region is moving towards the mean position, yes or no?
Yes, sir.
This green, they are moving.
Away.
This pink, they are moving.
Towards.
This green, they are moving away from the mean position. Do we understand this?
Yes, sir.
Pakka?
Pakka, sir.
Yes or no? Or this has gone above our head saying bye bye? Huh?
We got it, sir.
Pakka? Have you noted it down, everyone?
Done, sir.
One more thing we have to understand. Again, from the same y-x graph. The graph has not changed because you will only get the graph of y with x ever in a question. So again, this is the graph between y and x. We have seen which particle, again, this is a snapshot of a wave at one particular instant. We have seen how the velocity of different particles are. Now we'll talk about their accelerations. We'll talk about their accelerations. Let me use a different color ink. Let me use, so this is point A, this is point B, this is point C, and this is point D. From O to A, which point, okay, from O to A, what is the direction of acceleration? Direction of acceleration.
Towards the mean position.
So it will be downwards, yes or no?
Yes.
Remember, your mean position is here. From O to A, what is the direction of acceleration? Down or up?
Towards mean positions.
Down or up?
Down, sir.
Which point will have maximum acceleration?
A, sir.
A will have maximum acceleration, and what will be the value of that maximum acceleration?
A omega square.
So this point has a maximum acceleration, and the maximum acceleration is omega square A. While I move from here to here, the acceleration slowly decreases, and at this point, the acceleration becomes 0. Do we understand this?
Yes, sir.
From A to B, what is the direction of acceleration?
Upwards. Upwards.
From A to B, what is the direction of acceleration?
Downwards, sir.
Acceleration has to be always towards the mean
Yes.
position. It cannot be away from the mean position. So again, the same thing follows. As you go away and away, it becomes 0 at this point. So in this red zone, in this pink zone, all the particles have acceleration towards their mean position only. Do we understand this?
Yes,
And this has
sir.
gone above at saying bye bye. B to C,
Up. Upwards.
which point will have maximum acceleration?
C.
So the acceleration will be like this. And as we come towards the mean position, the acceleration becomes 0. Between C and D,
Upwards.
do we understand how
Yes.
we find out this and this? Acceleration is very simple. V is the negative of that, negative of the slope. And that is how we find out the direction of acceleration from this graph, direction of V from this graph. And this is the most important aspect that gets a lot of students confused. How did we get this and how did we get that? I'll give you 2 minutes to note this down. Draw the diagram, note it down. We have found out the first derivative here and the second derivative also here. We have seen the relation between Vp and the first derivative. Vp was negative of Vw into del Vy by dx. Similarly, I can find out the relation between the second derivative of y with respect to t, which is your acceleration, and the second derivative of y with respect to x. Can you tell me what is that relation? So basically, we are looking at the relation between this one and this one. What is the relation between this one and this one? What is the relation? Anyone? No one?
Yes.
Okay, I don't have so much time that I can give you for this. The relation between this and this will be, and I write it here, acceleration, the particle acceleration, which is nothing but del uy del 2y by del t square will be equal to v square times del 2y by del x square. That is the relation that we will get between acceleration, if you want to call that as acceleration, between acceleration and del 2y by del x squared. That is the relation that we are going to get between del 2y by del x square and del 2y by del t square. That is known as the differential equation of a wave. That is known as the differential equation of a wave. We had seen the differential equation of a SHM. Does anyone remember what was the differential equation of a SHM? Do you remember what was the differential equation of a SHM? Huh? Anyone remember the differential equation of a SHM? See, you forget things. I don't know. How will I help you out? You forget things. The only thing you have to forget is the habit of forgetting. But that is the only thing that you don't forget. What is the differential equation of a SHM? Huh? You don't remember it, sir.
dx square, sorry, d square x by dt square plus kx by m equal to 0.
Huh?
d square x by dt square plus kx by m is equal to 0.
I have to go back so much in the past to tell you this. That was your differential equation of a SHM. It was written in terms of x. You could have written it in terms of y also. Doesn't matter. What to do with you people? Can't do anything. Can't do anything. Anyways, I will have to let go the disappointment and write the equation again. d2x or d2y by dt square plus omega squared x is equal to 0. That, my dear friend, was known as the differential equation of an SHM. Differential equation of an SHM. Differential equation of an SHM. Now we have the differential equation of a wave. And the differential equation of a wave looks like this. Del 2y by del x square. Del 2y by del x square is equal to 1 by v square into del 2y by del t square. This is known as the differential equation of a wave. This one is known as the differential equation of a wave, of a traveling wave, I must add, traveling with a velocity v. This is the differential equation of a SHM that has an angular frequency, omega. Beautiful they look. Beautiful. Any wave which is traveling in nature should be of this form. So the differential equation of a wave, any wave will have an equation of this type. Any wave which satisfies the wave equation is a wave, is a traveling wave. Any wave which satisfies this equation is a traveling wave or a progressive wave. Any wave where y can be represented as a function of x and t. We have seen it in the form of a sine wave, but it may not be of the form of a sine wave. Sine wave is one of the simplest wave that we can understand. That is in our course. But any wave in the form of x and t, where y is given as a function of x and t, where you can vary both x and y, is the equation of a wave, is the equation of a traveling wave. But you must remember that one more condition, the value of y must be finite at all times. Must be finite at all times. If we have these conditions meeting, then that equation becomes the equation of a wave, my dear friend. Do you understand this, or you just gone above it saying bye bye, sir? Bye bye. I'm going, sir. Bye bye.
I understand, sir.
What do we understand, sir? You understand, sir? I know that, sir. But after understanding, sir, we forget it, sir. And that is the only thing that you have to forget. Is that you should not forget these things. Anyways, I hope you understand this. This is the equation of a wave, general equation of a wave. General equation of a wave. Three conditions given. It must be satisfying this wave equation. It will always satisfy the wave equation. If it is given in the form of x and t, it will satisfy the wave equation. It must be in the form of x and t, and it must be finite at all times. Should not have infinite value. Y should not have infinite value. Do we understand this, or this has gone above our head saying bye bye, bye bye, and bye bye? You understand this?
Yes, sir.
Huh?
Yes, sir.
Now this is one question. Which answer I need from you? Which of the following functions represent a traveling wave? Ta, ta, ta. Which of the following functions represent a traveling wave? I'll give you 2 minutes. Take a deep breath and tell me if you understand this. That means you have understood traveling wave. Then I will congratulate you. 2 minutes you have to show me your talents.
C, sir.
So, which of these waves, which of these equations represent a wave, my dear friend?
C, sir.
Which one?
C, sir.
A, B, or C, or D?
A or C, sir.
A or C, sir? The answer is C is the equation of a wave. C is the equation of a wave. Now, you look at A, B, C, and D. All are as a function of x and t. Everyone is given as a function of x and t, so they satisfy one condition, that y has to be given as a function of t. We understand this? But the only thing is, they should have finite values at all points, at all times, and at all positions. X minus vt. Now when x becomes very large, it becomes infinite. So it cannot be infinite. So this cannot be a traveling wave. Do we understand this? Yes or no?
Yes, sir.
It does not represent a finite value. At some point it will become infinite, not a wave. ln of 0 is not defined. It can become 0. So this is not a wave. Yes or no?
Yes, sir.
When x becomes minus vt, this becomes 1 by 0, infinite, not defined. It's not giving finite values at all points. Now, in the C part, whatever you do, you'll always get a finite value. Yes or no? And therefore, it represents a wave. Do we understand this, or this has gone above our head saying bye-bye, sir? Forgive us, sir. Do we understand this?
I have a doubt, sir. But C can never be equals to 0, no, sir.
So what?
So there is no problem at all, sir.
No, there is no problem at all.
Okay.
It should give finite values. It's
Okay,
not
sir.
coming to 0. Therefore, the mean position is not at 0. It is someplace else, somewhere else. Doesn't matter. Do we understand this, or this has gone above our heads? Saying bye bye, bye bye, bye bye. Huh?
We understand, sir.
Bakka sir?
Yes, sir.
Then you have a small question, sir. I'm very happy with your progress. Not many students understand this wave function, and I normally avoid taking this. This one. Remember, all these questions are going to come in JEE Mains and JEE Main when it is tough, JEE Advanced when it is tough. Question number 2. A wave pulse is just a pulse, single pulse. Doesn't matter, it's a wave. Moves along the x-axis is represented by this wave function, where x and y are measured in centimeters and t in seconds. In which direction is the wave moving? Find the speed of the wave. The third is plot a graph. They will not ask you to plot a graph. They will give you a graph and they'll tell you which is the graph at t is equal to 0 seconds. Yes. In which direction is the pulse moving or the wave moving? And you don't have to apply rocket science. You just apply what I had told you way before. Yes. In which direction is the wave moving? And the answer is, huh? Yes. What is the answer? In which direction is the wave moving? Are? Either it is positive x or negative x. Why are you think so much?
Positive, sir.
It is in positive. Why it is in positive? Because there is a negative coming in between. Do we understand this?
Yes, sir.
So this wave has to move in this direction, which is the direction of positive x-axis. Do we understand this, or this has gone above our head saying bye-bye? Bye-bye?
We got it.
Huh?
We got it, sir.
What is the speed of the wave? Simplest question in the entire universe. I've given you so many questions on waves. That is why.
Sir, speed is 3 centimeter per second.
Yes, coefficient of t divided by coefficient of x. Coefficient of x is 1. Coefficient of t is 3. So the wave speed has to be 3. Do we understand this?
Yes, sir.
So the wave speed has to be 3. Now the next part of the question is plot the wavefront. Let us not do it for t is equal to oh god. Machines, when they get bored, they get exhausted. They what? They do things like this. The next thing is plot the waveform, and they are not going to ask you to plot the waveform. They are going to ask you what is the waveform. They will give you 4 diagrams and they'll ask you what is the waveform at t is equal to 0. Don't worry, don't panic. What you got to do is just put the value of what? T as 0 and see the waveform. When you put t as 0, what is the function like? So it is at time t is equal to 0. How is the wave looking? Do we understand this? Snapshot of the wave. So it looks like this form. Yes or no? So out of the graph that they will give you, you just find out which graph is this one and you just mark it tick. Do we understand this?
Yes, sir.
Yes or no?
Yes, sir.
Pakka, sir?
Akka, sir.
Okay. Anyone understood this question, sir? I'll give you 1 minute to note it down. Have you noted it down, bacha?
Sir.
Everyone?
Yes, sir.
Okay. I was looking for a question. Now we come to the reverse part of this question. And this is the reverse question. Call it the reverse question. This is the reverse question of this. Reverse. A wave pulse traveling on a string at 2 meters per second. The displacement y of a particle at x is equal to 0 at any time t is given by this equation. So they have not given us the wave equation, they have given us the equation of a particle which is at x is equal to 0. The equation of a particle at x is equal to 0 is given by this equation. You have to write the wave function for this, and if you can do this, well, I must congratulate you then once again. How will you get the expression for the wave function? The next part of the question is very simple. The shape of the pulse at t is equal to 0. Once you get the wave equation, you can get the shape of the pulse. Yes or no? So the only thing you have to find out here is the expression of the wave function of the wave, and I'll give you 2 minutes. If you can do it on your own, it's very good.
We will do,
It
sir.
is very good if you get the equation on your own. If you can't do it, well, I will help you out. 2 minutes you have. Okay, I'll help you out on this.
1 minute, sir. We are doing, sir.
Okay. You're doing it. I'll give you time then.
Sir, it's
Yes.
8 by x minus 2t whole square plus 4, sir.
What? Tell me.
8 by x minus 2t whole square plus 4.
8 by
X minus 2t
x minus 2t
whole square
whole
plus
square
4. Plus 4.
plus 4. How did you get it? That is absolutely correct. How did you get it?
Sir, I found K value.
K.
K equals to omega by V.
Okay.
And when we transform that, this, I mean, at x equals to 0, he has given so that x is eliminated. In before it would be some kx minus t or t minus kx whole square plus some constant. So I have substituted k in place of that constant. So I got this.
Great. Well done. Good. I'm really happy that you could do this. This is absolutely correct. Now, just to give you what we are saying, beta, was absolutely correct. Just to give you what you had to do in very short. Now, y, which is given as a function of x and t, is the equation of a wave if it is finite at all points. And remember, this is finite at all points. Whatever you put, you will never get zero, or you will never get infinite or undefined answer. This is the equation of a traveling wave. Now y is given as a function of x and t. You can also write this equation if y is given for x is equal to 0, and in place of t you put t minus x by v. Which is same as you just write the function as t minus x by v for a wave which is traveling in the positive direction of x-axis. This is same as what you were saying, that I found out the value of k. The value of k is the coefficient of t divided by the coefficient of x. That is nothing but your value of v. Yes or no?
Yes,
So
sir.
basically, if you are given this equation, you just have to put, this is the position of the particle. The position of the particle is constant, x is equal to 0. So wherever you find t, you just replace this t by this value. That is what you have done. And you get the equation of the wave that we are traveling. So the equation of the wave simply becomes y is equal to 2 by, in place of t, you have written it as x minus vt. Doesn't matter. I could have written it like this. T minus
Minus x by v.
x by 2. You understand? Velocity is 2.
Yes, sir. Yes, sir.
T minus x by 2 square plus 1 is the same answer. If you
Yes, sir.
solve it, you will get the same answer. Absolutely correct. Similarly, if you have a wave, this was for a wave traveling in, positive x-axis. For a wave traveling in negative x-axis, what do you do? Y should be a function of x and t. That can be written as y as a function of when x is 0 or when the time is t plus x by v. Do you understand this? So
Yes,
it
sir.
becomes a function of t plus x by v. So this will give you a wave which is traveling in the negative x-axis.
Yes, sir.
And now once you get the wave function, to find out the shape of the pulse, you just put t as 0 and you will get the shape of the pulse at t is equal to 0. You put the value of t as 1 second, you will get the value of, no, you will get the waveform of the wave at t is equal to 2 seconds. Do we understand this, everyone?
Yes, sir.
These are the most difficult aspects of understanding in a wave equation, and I normally don't do it. I just tried. Okay, let me see if I can do it. And it's good that you understand this. These questions are only going to come in your JEE Advanced, and I will just show you, just for your knowledge, that if this question comes, the wave of the shape of the wave at t is equal to 0 is going to look like this, because I have this as my I have this in my notes. So this is the shape of the wave at t is equal to 0. So basically it is y upon y is equal to 2 upon x square, or 8 upon x square plus 4 square ka curve. Do we understand this?
Yes, sir.
And a beautiful thing here is, if you see the value of the graph of the shape of the wave at t is equal to 2 seconds, you can see this pulse. This pulse, it was initially here. Do we see this? This pulse was initially here. It has moved ahead by 2 seconds. Do you understand this? Now you understand how this pulse is moving. So if you take this snapshot, at every second, you will see this wave moving. Do you understand this? So this
Yes.
is the next position of the wave at t is equal to 2 seconds. Do we understand this, or this is going above our head saying bye bye?
We understand, sir.
Pakka?
Yes, sir.
So you can do this one. This will give you an understanding of how wave is, how wave travels, and what do you mean by snapshot of a wave, picture of a wave. This is the next question. Since you have done the previous question on your own, this should be a simple question. Question number 4. This should be a cakewalk. Tell me the wave function first. Wave function of this wave. Once you know the wave function of this wave, rest all should be simple. Huh? No answer? I'll give you 2 minutes to do this. Yes.
Yx comma t is equals to
Yx comma t is equal to wave function
60 by
6 by
60, sir, 60.
60. How did you get 60?
Sir, I have taken that 45, 4.5 as 45 by 10.
Okay, okay, ठीक है. But again, that will not be 60. That will be more than that. 10 square comes 600. It
10
will become.
square, 600.
Don't make it like this. Just you can write it like this. X.
And it will be then x plus x minus 4.5 t whole square plus 3, sir.
Yes. So you can write it like this. T minus x by 4.5 whole square plus 3. You can just write it in this form. Okay.
Okay, sir.
You don't have to take it too much. You can just write it in this form. Simplification can be done later on. Do we understand this?
Yes, sir.
Okay, that takes us to the next thing. Now we are moving into transverse wave. Now remember what we have done up till now. We have not spoken whether it was a transverse wave or a longitudinal wave. Same thing remains valid in all waves, whether it is wave speed or wave form or this or that. Everything remains same. Yes or no?
Yes, sir.
The only thing is transverse wave goes like this, so you have the waveform like this. In longitudinal wave it will be compression and rarefaction, so you will not get question on waveform only you will get questions in transverse wave. Do we understand this?
Yes, sir.
Now you can move on to the next thing, and that would be speed of transverse wave.
Sir, I have one more doubt, sir.
Yes.
Sir, what if x square has coefficient or t square has coefficient?
Sorry.
In the previous case,
Yes.
If x square or t square has coefficient like 3, 4, something.
Give me an example. What do you want to say? Give me an example of a wave.
Sir, here equation is given as y equals to 6x cube plus 3, no sir.
Okay.
If that x cube has some coefficient as 9,
So what difference does it make?
means that coefficient shifts where that coefficient will shift. Sir, if x cube, sir, cube has coefficient of only cube.
Okay, you can take the example. Let's not make it as cube. You can take the example like this. You want to write it as 2x square plus 3. That is what you want to say. Like this. So what difference does it make? Instead of x, you put t minus x by v. Or instead of t, you put t minus x by v. Do we understand this? Am I clear? Just in place of x, you put that, and you will get the rest of the things on that thing as well. Don't worry. Or if you have this equation, you can write it this way also. See, you can just uh, take out 2 common, and you can write this equation as 3 divided by x square plus 3 by 2. Now you make the coefficient of x as x only. You just taken it out, and you can now write the wave equation. Do we understand this? So whether the equation is given in the form of a function of x or a function of t, what you got to do is convert it in the form of t minus x by v or t plus x by v. Doesn't matter. Okay? We understand this? Okay. Now the next topic that we have is the speed of a transverse wave in a string. And to understand this, what you do is you just have a string. It would be a wire in this case, and you hang a mass with this wire. Now, as soon as you hang a mass with this wire, this string will have tension. Yes or no? Okay. Now we are not going to go into much detail. What we are going to do is write the speed of the transverse wave in this, and that will be equal to t by lambda. So what is lambda? Lambda is mass per unit length of the string. Remember, the speed of a wave in a medium does not depend on frequency, does not depend on other things. It only depends on the medium itself. So in the case of string, it is equal to t by lambda ka root. Do we understand this? Yes?
Yes, sir.
Or no? Okay, I will give you 2 minutes to note this down. Let us move ahead and solve this question. It's a simple question just to get you a hint of what is coming up. So you have this string hanging from a mass hanging from a string, and you have to find out the speed of the wave generated in the spring. If you generate a wave in this string, what will be the what will be the what? What will be the speed of that wave in that string? give you a minute to do this. I hope you have read the question carefully. Yes or no?
Sir, it is 20 meter per second, sir.
From 2 root 10, answers become 20. Yes, it is. Just have to apply the formula, beta.
Okay, sir. Sir, I have taken that kg meter.
I know what you have taken. You must be careful. This is how you will be. So this is 200 Newton tension divided by 0.5 kg per meter cube. So that is your answer. Do we understand this, or this has gone above our head saying bye bye?
Understood, sir.
Pakka na sir?
Yes, sir.
Or kacha?
Pakka, sir.
Anyways. Chalo, let's move on to this one. Interesting question. A taut string having tension 100 Newton and linear mass density 0.5 kg per meter is used inside a car to generate a wave pulse starting at the left end as shown in the figure. What should be the velocity of the cart so that the pulse remains stationary with respect to ground? A very simple and a very elegant question. I love this. I'll give you 2 minutes for you to share my feelings. 2 minutes you have. That means if the pulse is moving from left to right, this should move from right to left. Is that so? Okay, I think that is correct. How do I solve this? First of all, I find out the velocity of this pulse, t divided by lambda. Yes or no?
Yes, sir.
And I will get it as 20 meter per second. Yes or no?
Yes, sir.
But that 20 meter per second will be the velocity of pulse with respect to the cart. Yes or no?
Yes, sir.
Now, velocity of pulse with respect to ground will be velocity of pulse with respect to cart plus velocity of cart with respect to ground. Do you remember that? I used to put one C in between, and that is how I got.
Yes, sir.
Now, this has to be 0. Velocity of pulse with respect to cart is 20I. So, what will be
Yes,
the
sir.
velocity of cart with respect to ground? Velocity of cart with respect to ground has to be minus 20I. So in that case, the pulse will remain stationary, will look stationary with respect to ground. Do we understand this, or this has gone?
Yes, sir.
Saying bye bye? Bye bye?
Understood, sir.
Now, we are not going to solve this question. This is a question that you are going to keep as a thing that you remember. Now, before going on to this question, and let me tell you what this question is all about and what we had done previously. Now, if you remember the question that we had done previously on this tension, there was a very important aspect of the question which I did not tell you then. In the question, there was a very important aspect given, and I did not pay any attention to it. I did not emphasize it. What was that point that I did not emphasize?
The tension is not affected by the mass of the cord.
The tension is not affected by the mass of the cord because we have taken the length was not given first of all. Anyways, forget about the length. We had assumed that the mass of the cord is very small compared to the tension that this body that this block was putting, and therefore we had neglected that part and we had only found out the tension which was created because of the mass only. Do we understand this?
Yes, sir.
But in reality, if you have and I'll go back to this, But in reality, if you have a cord hanging like this, and this cord or this rope has a mass m and length L, there will be tension in the rod because of the mass itself. Yes or no? Because of its hanging mass itself, it will have tension. Yes or no?
Yes, sir.
And at which point is the tension going to be maximum, and at which point is the tension going to be minimum? At which
Sir, at the
point?
ceiling, the
At
tension
the
will be maximum, sir.
at the ceiling, the tension would be maximum, and at the lowest point, the tension would be minimum. In fact, it will be zero. Yes or no?
Yes, sir.
So this rod will be subjected to a variable tension. The formula that we gave was the velocity of the wave when the tension was constant. Do we understand this?
Yes, sir.
It was the formula when the velocity was constant. Here, the velocity of the wave would be variable. Do we understand this?
Yes, sir.
We'll not go into how we are solving it because that will not serve any purpose. What we have to understand, at this point, which is the lowest point of the rod, the tension would be zero. Yes or no?
Yes, sir.
And therefore the velocity would be zero. Yes or no?
Yes, sir.
If I go a distance y up, and if I call that velocity as v of this wave, remember this is a wave moving with, remember this is a wave moving with, remember this is a wave moving with different velocity at different points. You must remember that the velocity at this point will be given by root over gy, which is what this question wants us to prove, but we will not prove it because we will know the answer and we will just use it. So the velocity of this wave at a distance of y from the bottommost point will be given by this formula. We will keep it as a formula and do not do anything about it. At the same time, they might ask you how much time will this wave take to go from the lowest point to the highest point. You will remember that time as well. That time will be given by 2 times root over L by G. We will remember this as a formula and not think too much about it. Do we understand this?
Yes, sir.
Draw this diagram and write a very big important note here. Draw the diagram. You may not write the question, but that write the formula. So take it as a formula. I'll give you 2 minutes to note it down. Having done through this, now we must understand what is the purpose of a wave. What does a wave do? What does a wave do? What was the main function of a wave? What was the definition of the wave, if I may ask? Coming from starting point to now, what was the function of a wave? What was the wave doing?
Vibrating particles.
What?
Wave is a vibrating. Wave is a vibrating particle.
Wave is a vibrating particle.
Sir, wave
Yes.
is
Sir, wave is disturbing the particles of the medium. Main function is that.
What is the wave? See, you have forgotten the basic definition of a wave. We have done almost half of wave, and now I ask you what is wave, and everyone is like, okay, what is wave? No one knows what is a wave. I'll give you 2 minutes. Tell me what is wave first. So we understand what is the wave after 6 hours of classes. We have understood what is a wave. Wave is a disturbance.
That propagates and which transports energy and momentum without the transport of
It
matter.
transfers energy and momentum without the transfer of particles. Particles don't move, particles oscillate, and energy is transferred. So that is the main thing that a wave does. A particle also transfers energy, but that is by the motion of the particle. Particle goes from one point to other point and it transfers momentum and energy. But wave particles remain at the same position, but still momentum and energy is transferred. So the main thing is that we must know what is the energy or the energy or the power transferred in a wave. So that is the next setting. The most important aspect for a wave is power transmitted. Power transmitted. And whenever I am talking about power, I am going to be talking about the average power which is transmitted by the wave. Average power means in one time period, how much power the wave transmits. That is what we will be thinking about. That is what we will be talking about, the average power transmitted. Now remember this formula in whatever ways you can. The average power transmitted by a wave in one time period. Take a deep breath and understand it carefully in different ways so that you can remember them. The first way is you can write it like this: 2 pi square f square a square lambda into v. This is power transmitted by a string wave. So just write string wave. Wave on a string. Now, can you tell me the meaning of the terms that are coming here? Huh?
Sir, F is frequency, A is amplitude, lambda is wavelength, V is velocity of
Okay,
wave.
lambda.
Wavelength, sir.
No. Let me change this. To change this, I will have to go back. Go back. Mistake. So I will change it here. Let me not call this lambda. I forgot. I always use lambda for mass per unit length. Let me not call it lambda. Let me call it mu. So I change it here to mu. Mu. Mass per unit length. Mu.
Sir, that
E
is
by
mass
mu.
density, sir.
Yes, that is mass density. Mass per unit length mu. So wherever I had written lambda for mass per unit length, change it to mu. So I change this one for mu, not for lambda. Sorry, big mistake. Lambda was for wavelength. I should use different symbols, otherwise symbols get confused. 2 pi square f square a square mu v. Yes. What is mu?
Mass density.
Mass per unit length of this. Mu is mass per unit length, remember.
Sir, if it is given aerial, so we can consider aerial also, sir.
Normally in a string, it will be given mass per unit length, or it will be given. We'll come to that. What will be given? V is what? V is the wave velocity. Yes or no? V is the speed of the wave. Do we understand this?
Yes.
Now F can be written as omega by 2 pi. Yes or no? So I could write it like this also. Half omega square a square mu v. This is the form that I remember. This is the form that I remember. Have we noted this down? This is the power. Okay. Now, sometimes they might ask you what is the energy transferred in one time period. Energy, let me call this as energy. Energy transferred in one time period, that will be equal to P average multiplied by T. We multiply this by T. Half omega square A square mu V T. This is the energy it will transfer in one time period. This is also equal to the energy stored in one wavelength. So you can remember this in two ways. This is the energy transferred. This is the energy transferred in one time period. Or you can also remember in this way, this is the energy stored in one wavelength. Do we understand this? Do we understand this?
Yes, sir.
Okay. The next thing that will come is the intensity of the wave. Whenever we talk about wave, we talk about intensity of the wave. Anyone heard this term intensity of the wave before? Huh? Anyone heard about this term intensity of the wave before?
No, sir.
Intensity of anything is energy per unit time per unit area. Per unit time per unit area is the intensity. Energy per unit time per unit area. Or therefore I can also write intensity as power, which is energy per unit time divided by area. Do we understand this, or this is gone above it saying bye bye? Huh?
Understood.
Now I have this legendary formula for this intensity, and you must not forget it, whatever happens. Half rho omega square A square into V. Now, what are the meaning of terms here? What does omega stand for?
Angular frequency, sir.
What does A stand for?
Amplitude,
What does V stand for?
velocity of wave,
What does rho stand for?
density of the medium,
Density of the medium now. Now, this formula becomes valid for all types of waves, whether it is longitudinal wave, whether it is any wave. Do we understand this? Because rho is the density of the medium now. It was not mass per unit length, because in air you cannot find out mass per unit length. Do we understand this? What is the mass per unit length of this air? You can't, but you can find out the density of air. We understand this, yes? It has gone above our head saying no. And this becomes the universal formula for a wave. And whenever we talk about wave, we normally do not talk about the power of the wave. We talk about the intensity of the wave. And this is the average intensity of the wave. Average power per unit area per unit time it will give in one time period. Do we understand this? or it has gone above, or it's saying bye bye, sir. बहुत हो गया सर, छोड़ दो सर, माफ कर दो. Bye bye.
Understood.
Now we can see on what all factors this intensity depends on, and this is going to come in the entire chapter on wave, whether it is wave optics, whether it is wave this, whether it is wave that, whether it is wave this. Now, intensity depends on what all factors. Oops, what I'm writing now. Intensity depends on what all factors, and remember this, intensity is directly proportional to rho. That means the density of the medium. Therefore, depends on the medium on which the wave is traveling. Yes or no? Yes or no?
Yes, sir.
Intensity also depends on the speed of the wave. Now, these two things basically come from the medium, because depending on the medium, you will have different density and you will have different speeds. Yes or no? No or yes? Speed depends on the medium. Density also depends on the medium. So these two terms are coming from the medium. Yes or no?
Yes, sir.
Intensity is proportional to amplitude square, a very important term. If you make the amplitude twice, intensity becomes 4 times. And this is a very important term, because in the entire chapter on waves, this will be coming in various forms. In the entire chapter on waves, this will be coming in various forms. Now, once you change the medium of the wave, rho and v will change, and therefore the medium will change and intensity will change. Yes or no?
Yes, sir.
How will you change the amplitude of the wave? If the wave, this is a traveling wave I have, and it is striking a boundary between two medium, reflection, it is striking a boundary between two medium. Now the entire wave will not be reflected, and the entire wave will not be reflected, and the entire wave will not be refracted. Yes or no? Some part of it will be reflected and some part of it will be refracted, so that will change the amplitude of the wave. So intensity of the wave will also change. Do you understand this? If the amplitude remains same, the intensity of the wave will remain same. Do we understand this?
Yes, sir.
Intensity of the wave also depends on f square, or you can call it omega square. That means it depends on the source. What is the source? Because the source is going to give you the frequency. Yes or no? So how can you change the intensity of the wave? If the wave remains in the same medium, if the wave remains in the same medium, you can only change the intensity by changing the frequency. You have to change the source. But if the wave goes in different mediums, because of change in rho and change in v, the intensity of the wave will keep on changing. Yes or no? Similarly with the amplitude. Do we understand all these terms now?
Yes,
Half
sir.
rho omega square a square v. The last thing we have to understand is energy density. Energy density of a wave. What do you mean by energy density of a wave? This energy density term is going to come a lot of times, starting from the next chapter. Electrostatics, energy density of electrostatic field, energy density of magnetic field. Have you heard this term, energy density? Energy density simply means energy per unit. Per unit what? Energy per unit. Oops. Energy density simply means energy per unit what? Energy per unit volume. Do we understand this? Energy per unit volume is known as energy density. I write it as du by dv. Small energy divided by small volume. And this du by dv can be found out intensity divided by the speed v. Intensity divided by the speed v, and therefore the formula for this becomes half rho omega squared into a squared. Now I will give you 2 minutes, 3 minutes. Go through all these formulas. You have to be very thorough with all these formulas, because otherwise the question on this part you will not be able to do. So now, starting from this power and energy, I'll give you 2 minutes. Take a deep breath and read all these formulas. Then I will move ahead and give you a couple of problems. Oops. Oops. Okay, I'll do it this way. Just give me time to 1 second to put this question. And the question looks like this. Two waves are traveling in the same medium are represented by YT curves as shown in the figure. Find the ratio of their average intensities. I'll give you 2 minutes to give me the answer. 25 by 8, sir. I'm afraid is not the correct answer, sir. How did you get it? Let me call the intensity of this wave as
Sir,
I1.
no, sir. 25 by 16, sir. Okay.
Yeah, small mistake and you are done. Okay, that is correct. 25 by 16. So I have to find the
Yes, sir.
ratio of I1 and I2. That will be equal to half into rho into A1 square into omega 1 square into V1 or V divided by, that is why, half rho A2 square omega 2 square into V. Now, knowingly I have kept something similar and knowingly I have kept something different. What have I kept similar and what I have kept different? Huh? Half, apart from half. This rho and rho are same. Why are they same?
Sir,
Yes.
medium is same, sir.
V and V are same. Why are they same?
Source. Medium is same, sir.
Medium is same, sir. That's it. So I1 by I2. Amplitude of the first wave is 5 square. Yes or no? Amplitude of the second wave is 2 square multiplied by the angular frequency. Angular frequency. You can see the angular frequency or frequency of the first wave is half of the second wave. Yes or no?
Yes, sir.
Because in the time that the first wave completes one half cycle, it has completed one full cycle. Yes or no? The frequency is 2 times. Yes or no?
Yes, sir.
So 1 divided by 2 square, and therefore your answer becomes 25 by 16. Do we understand this, or this has gone above or is saying bye bye?
We understand, sir.
Then one more quick question. Do it fast. Okay, I'll give you that question afterwards. Let me just, since we have come so far, let me give you one more concept, and that concept is the power and intensity of a point source. power and intensity of a source. Now, this source can be a source of light, because you understand that light is a wave, yes or no? Huh?
Yes, sir.
Hmm. Light is a wave, it has energy. Sunlight, electromagnetic wave, energy. I have a point source. Now, this point source, let us say, is at point P, and I have this point A, which is at a distance of R from this point source. Let me call this point source as point source O. It is at point source O. Now, if I say that if P is the power of this source, if P is the power of this source, you must understand that this point source is going to emit power in all directions. Yes or no? This is a point source. It will emit power in all directions. It will emit energy in all directions. Yes or no? Yes or no? In the form of
Yes,
a
sir.
sphere. This is just like that gravitational field. Gravitational field due to a point mass is always going everywhere. Yes or no? If someone asks you what is the intensity of this power, intensity of this source at point A, what you got to do is you have to divide power by 4 pi r square. Why this 4 pi r square? Because it will be emitting power in the form of a spherical thing. Do we understand this?
Yes.
So I can say for this point source, intensity is proportional to 1 by r square. Do we understand this?
Yes, sir.
Or if I talk about the amplitude of this wave that it's creating, the amplitude will be proportional to, inversely proportional to r. Do we understand this? Do we understand this?
Yes, sir.
Now similarly, if instead of a point source you have a line source just like your tube light is a line source, line source, line source. Well, this is just like a line mass. You remember gravitational field created by a line mass? I had given you the formula, yes or no?
Yes, sir.
And we will see how they are similar. Just now you can write the formula. Similarly, if you have to find out the intensity due to a line source at any point A, which is at a distance r from it, you will find it out in this way: P divided by 2 pi r L, where L is the length of that light source actually. Okay. So in this case, you can see intensity at point A will be proportional to, inversely proportional to R, or proportional to 1 by R, or you can say the amplitude will be proportional to 1 by root over R. These are the two things that you should remember. Have you noted it down? Do you understand this?
Sir,
Yes, beta?
sir, there.
Sir, why is 2 pi RL in denominator?
L is the length of that source. Just write it. Just write it. This is the same formula as gravitational field created by a line mass. Did I give you that formula? Lambda by 2 pi epsilon naught r. Did I give you that formula in gravitation? Don't worry, we will see this. Right now, just remember this. 2 pi RL, it's in the form of cylinders. That is why 2 pi RL. The line source emits cylindrical wave fronts. We'll understand this, don't worry. Right now, just note it down, because this is the point where you can note it down and I remember it, otherwise I'll forget it. Have you noted this down?
Like this also you can consider point source emit like point source emitting infinite point sources emitting on that line L.
Just remember it this way. Just remember it this way.
Okay, sir.
Right now, don't get confused. I will tell you more things in the coming classes. Just remember it like this. Okay, just remember it like this right now. 2 pi r is the circumference of a cylinder, so it emits in the form of a cylinder. Pi r square, 4 pi r square is the area of a sphere, it emits in the form of sphere. Just remember that way. This is spherical or sphere, spherical or sphere. This is cylindrical or cylinder shape. Just remember this. Just remember this. Have you noted this down?
Yes, sir.
Then I will give you a question for homework. You noted this down now? You noted this down? Everyone? Have you noted it down, bacha?
Yes, sir.
Then comes this question, which I am giving to you as a homework. So this is the homework question. A transverse wave of amplitude 0.5 mm, amplitude is given. Remember the units. Frequency 100 hertz is produced on a wire stretched to a tension of 100 newtons. The wave speed is 100 meter per second. What is the average power the source is transmitting to the wire? I will also give you the answer for this so you can check it. The answer that I have is 49 milliwatt. So just check whether you get this answer or not. You just have to apply the formula. There might be some calculations. Remember, whenever you get caught in pi square, remember the value of pi square is approximately equal to G, which is 9.8. A very important thing that might help you in calculations. Since that is 9.8, therefore you are getting 49 somewhere here. Okay. So remember this pi square value can be taken approximately equal to 9.8, which is G. So you can cancel pi square from G at points where you feel like. Okay. Have you done this, everyone?
1 minute.
Noted down this question? Noted down the question, beta? Okay, then with this question, we come to an end for today's class. We have taken lots of steps in today's class. In the next class, we'll move on to the other interesting aspect of this wave, which is superposition and interference. Almost 70-80% of question in wave, whether it is wave optics or wave mechanics or simple harmonic motion, comes from superposition of waves. And this superposition of waves is similar to what we had already done. We have done superposition of SHM. We are going to again do the same thing. So I'll see you in the next class. Everyone has noted this down? Everyone has understood what we have done in today's class? Go through this and please remember those formulas that I have given you. Take care. God bless all of you. Bye bye.